Assalamu alaikum dear students. Hope you are fine. You are utilizing this time in a meaningful way. In the yesterday's video lecture we did Theorem 8.6. It was that the diagonals of quadrilateral bisect each other. Parallelogram bisect each other. Now in today's video lecture we will do the converse of this theorem, that if in a quadrilateral the diagonals bisect each other, then that quadrilateral is a parallelogram. That is the converse of the yesterday's theorem. Converse means reverse. First we were given a parallelogram, we were required to show that it is diagonals bisect. Now we are given a quadrilateral, diagonals bisect. We have to show that this is a parallelogram. Let us prove this theorem. This is a parallelogram. Suppose this is a quadrilateral. A, B, C and D, and AC and DB are its diagonals. We have to show that and such that OB is equal to OD and OD is equal to OC. This is given. We have to prove that this is a parallelogram. So as usual, concept of congruence very important. With the help of that we can easily prove that this is a congruent. Have a look. First of all, we will write the given. We will write AC and BD are diagonals of quadrilateral ABCD bisecting each other at O. Bisecting each other at O. In the if you remember the yesterday's lecture, there were AB, AC and BD are the diagonals of parallelogram intersecting each other at O. Here it is AC and BD are diagonals of quadrilateral. Recall. Then we have in the previous theorem we were given parallelogram. We were required to show that diagonals bisect. Now we are given the quadrilateral, diagonals bisect. We have to show that this quadrilateral is a parallelogram. Hope you will get this question. You have now got the clear idea about the question what we are supposed to find. So to prove ABCD is parallelogram, have a look. What we will do is, look, if we are able to prove that triangle AOCB is congruent triangle to OAD, if we are able to prove that triangle OCB is congruent triangle to OAD, then we will write that this angle equals this angle, alternate interior angles, and from there we can easily alternate. If this angle equals this angle, these are alternative interior angles, we can say that this line is parallel to this line, because if alternate interior angles are equal, lines are parallel. We will write in triangles. In triangles, OAD and OCB. OAD and OCB, let us make them congruent. Very simple. OA equals OC. OA equals OC. This is given. OB equals OD. This is also given. Why? Because the diagonals of quadrilateral bisect each other. It is given. It is given that the diagonals bisect each other. These things are given. And we will write angle DOA equals angle BOC. Angle DOA equals angle BOC. Why? This angle equals this angle. Why? Because these are vertically opposite angle. So have a look. Let us check the criteria. Two sides and including angle. So by SAS triangle OAD is congruent triangle to OCB. Triangle OAD is congruent triangle to OCB. So what happens to the corresponding parts when the lines are, when the two triangles are congruent? What happens to the corresponding parts? You know that corresponding parts are equal, so we will write it here. If you look, name this angle 1, name this angle 2. So angle 1 equals angle 2. Why? Angle 1 equals angle 2. CPCT. Angle 1 equals angle 2. Why? Because CPCT. If you look, because we have here proved that triangle OAD, it is congruent triangle to OCB. So this angle equals this angle. These are alternative interior angles. Therefore AD parallel BC. If an alternative interior angles are equal, lines are parallel. So we will write, but therefore angle 1 equals angle 2, CPCT. Angle 1 is equal to angle 2, CPCT, corresponding parts of congruent triangles. But these are alternative interior angles. So when alternative interior angles are equal, recall the lines and angles chapter, then lines are parallel. Therefore AD parallel BC. Similarly here we will make this triangle OAB and OCD congruent, and we can get AB parallel DC. Similarly we can prove that, AD, here it is AD. Similarly we can prove that AB parallel DC. Similarly we can prove that AB parallel DC. Now AD parallel BC, AB parallel DC, yes, AD parallel BC, AB parallel DC. So if a quadrilateral opposite angle sides are parallel, then it is a parallelogram. Name this first, name this second. From first and second, we get that ABCD is parallelogram. So this was all about this theorem. What were we given? We were given a quadrilateral. Its diagonals bisect each other. We were required to show that this is a parallelogram. So with the help of congruence, we proved this theorem. Hope you will get it. If you still have any confusion or question regarding this, please let me know that. Thank you, class.